All right, here's our video today. Sugar in the blood. And the sugar is glucose. That is the preferred sugar in the body. Let's write that down. So, glucose. Any other type of sugar that your body eats, like fructose, for example, or maltose, will be converted to glucose. So, glucose in the blood, that should be the title. And then we have the subscript there, the storage of glycogen and insulin resistance, which we'll talk about in this video. And by the way, this is not a health video. Not a health video. Just giving you some scientific. Ooh, forgot the L there. Doesn't seem right there, right? Health video. Not a health video. Just talk to your doctor about things you may have heard in this video. So anyway, just basically when you eat carbohydrates, when you eat food, when it goes into the stomach and then eventually the small intestines, from the small intestines, glucose is released into the blood. And the second, that glucose is in your blood, the pancreas is going to be alerted and it's going to send out a hormone called insulin. That's very basic right here. So again, glucose enters your blood, insulin is released because insulin is going to bind to every cell in your body that needs sugar, and the sugar is glucose. So insulin is the hormone that's necessary to bind to cells. We'll talk about that in the video. So the cells can take in glucose. And what happens is if there's too much glucose, or if the cells had their fill, the excess glucose will be turned into glycogen. So you see this fancy word over here, glycogen. All right. Now the time that absorption takes, the time it takes for glucose to enter your bloodstream, could take anywhere between 1 and 2 hours depending on what you're eating and your metabolism and so forth. But in general, blood glucose levels should peak within 1 to 2 hours after eating. That's why when you get a blood test, especially when doctors checking your sugar levels, you should fast. And of course, the type of carbohydrates you're eating, like simple carbohydrates like sugary foods, they'll be absorbed more quickly. And that could be harmful in a sense, and we'll talk about that. But complex carbohydrates take a longer time to break down, so that's a good thing. So there's your pancreas, part of the endocrine system, hiding behind the stomach. And you can see once glucose is in the bloodstream, insulin will be released, and the insulin will bind. Well, here we have a cell, all your 36 trillion cells. And let's just say there's insulin, a crude drawing of insulin. And what insulin basically does is it allows for glucose to enter. It's like knocking on, give a little knock. It's like knocking on the door of the cell, so to speak. Let's change, say make glucose red. And all this glucose, or orange, will enter the system. And of course, when the cell has its fill and there's still excess glucose in the blood, it will be turned into, like I said before, glycogen. And we can thank insulin for that too. So insulin will allow, knocks on the door of the cell, allows glucose to enter the cell, and insulin, we'll write it over here, insulin will also help convert glucose, the extra glucose, into glycogen. All right. Be stored in the liver. Now, there could be a point if you're eating a lot, if you're eating a lot of carbs and so forth, or if a lot of sugar is in your body, then your liver could have its limit of glycogen. And in that case, the glycogen will be turned, right here, put a little arrow, will be turned into fat. So extra glucose turns into glycogen, and excess glycogen will be turned into fat. Now, the liver can store about 100 grams of glycogen, and that's usually enough for us while we're sleeping and so forth. And the muscles also, they can store glycogen. So in generally, if your last meal, let's say the last food you ate was at 5 o'clock p.m., Your glycogen reserves could be depleted by anywhere between 12 and 18 hours after that. It also depends on what you ate, how much you ate, and your physical activity. But remember, we always need energy. Your body always needs energy, so that's why ingeniously it stores glycogen, for so it can be converted back to glucose for that energy. And of course, if you run out of glycogen, that's when the fat reserves, the lipids, take over. So if you're consuming more calories than your body needs, regardless of the sauce, right? You need some little sauce for your spaghetti there. But regardless of that, it could lead to fat gain over time. So again, the body converts and stores excess energy and as glycogen, and if there is a glycogen limit, then it'll turn it into fat. And if this happens over time, this could lead to some issues like insulin resistance, which I'll talk about in the video, or type 2 diabetes. And again, you want to talk to your doctor about this. So excessive fat, especially around the abdomen, can lead to insulin resistance because fat cells release certain things in the body that could block insulin, and we'll talk about that. So one thing that having excess fat, especially around the abdomen and so forth, it could lead to free fatty acids. So I'll put free fatty acids, especially cytokines or cytokines, however you want to pronounce it. Now, cytokines, they are these free fatty acids, and they can interfere with the promotion of insulin. They can help in the wrong way, but they can promote insulin resistance by disrupting insulin signaling pathways on a cell. So on a cell, you have these signaling pathways where insulin could, so to speak, we'll say in a simple way, is find a place to land. And so if there's excess insulin in the blood because of all this glucose that's in your blood, then these free fatty acids, what they can do is they could disrupt that signaling. They can block certain things, these fatty acids, as you can see here, right? Here's a signal. It's a little blurry. And so when they block these signals, it's hard for insulin to attach to cells. So that's a danger right there. So just to make this a little simpler, when you have these repeated blood sugar spikes, by certain things that you're eating, the insulin response over time can lead to insulin resistance also because the cells are going to be less responsive to insulin. Also with these free fatty acids blocking some pathways. So we can say overproduction. Let's write this down. Overproduction. Overproduction. In other words, too much sugar in the blood. The cells will respond by blocking some insulin receptors themselves. So the cell is becoming overwhelmed because every time there's glucose in the blood, the pancreas is going to send out insulin, more and more insulin. If there's too much insulin in the blood, the cells are being oversaturated by insulin, so they will also limit where insulin could bind to cells. They're going to protect themselves. The cells are going to protect themselves from the effect of constantly having high insulin. And they'll reduce the number of insulin receptors, as I said before. Fewer insulin receptors for insulin to bind to leads to a decreased sensitivity to that hormone. And just basically when there's too much insulin and there's less insulin now, less receptors for the insulin to bind to, that means that the cells are taking less glucose. So here's a very oversimplified picture. You see the insulin like a key. So these glucose channels can open. If there's too much insulin, and remember, there's not just one hormone that attaches to a cell. There could be many, right? And let's say these were the insulin receptors, and let's say the cell is closing them down. There's just too much insulin coming in. So too much money coming in, right? Or you can close some. Let's say the trucks are coming in to deliver some goods, right? So let's close this, let's close that, let's close this, let's close that, let's close that. We have enough insulin in the blood, and why? Because of the excess glucose. So you have a twofold attack here. The cells are limiting insulin coming in because there's too much insulin. And why is there too much insulin? Because there's too much glucose. And if there's too much glucose, that means they're making the insulin is also making too much glycogen. And if glycogen reaches its limit, it'll make fat. And fat will, again, another attack, they will send these cytokines, however you want to pronounce it, into the blood to disrupt the cell's receptors anyway. So it's disrupting the cell's signaling activity. It's like you're being jammed with your cell phone. You're not getting cell phone activity. So if we look at, with healthy intake, once, you're having glucose, it gets converted to glycogen, any excess insulin comes in and it helps, it knocks on the door. And by the way, the insulin that attached to the cell will actually be eaten by the cell. It'll be broken down by other enzymes in the cell if it's available. And of course, if there's too much insulin, it may block that anyway. All right, that's our video today.